we have this matrix question here. Multiply these two matrices. So let's see what happens here now. We have 7, 20, 10, and 30. And we're going to multiply by 5, 8, 9, and 2. Here now, we multiply row by column when we multiply matrices, alright? Remember, this is row 1, this is row 2, going across, the rows go across. Then of course, what we have is column 1 going down and column 2 going down. Remember those things. Now, we're going to have a matrix as the answer here. This number that will come here is in row 1, column 1. This, let me put it a little bit further, is in row 1, column 2. Whatever you're going to write here is in row 2, column 1. That's the second row, first column. And here, whatever we're going to put here is in row 2, column 2. Alright? So remember, at the top is row 1. Going down, you have row 2, and so on and so forth. On the left is column 1, to the right of that is column 2, and so on and so forth. Now, what this means here is that we're going to multiply row 1 by column 1. So, it's going to be the first elements multiplied. First element in row 1 is 7, and the first element in column 1 is 5. So it's 7 by 5. So we have 7 times 5. Alright? Plus the second elements multiplied. Second in row 1, 20, times the second in column 1, 9. So what we have here is 20 times 9. See that? We follow the same argument for row 1, column 2. 7 times 8 plus 20 times 2. See that? So it's going to be 7 by 8. So it's 7 times 8 plus, so it's first elements multiplied, second elements multiplied. So it's 20 times 2. Alright? Row 2, column 1. Same argument applies again. Row 2, this is row 2 and column 1. So the first elements multiplied, 10 by 5, plus second elements multiplied, 30 by 9. So it's 10 by 5 plus 30 by 9. So it's 10 by 5 plus 30 by 9. Same argument applies with row 2 and column 2. Multiply. It's row 2 now. Row 2 by column 2. the first element in row 2 is 10 times the first element in column 2 is 8. It's 10 by 8 plus second element in row 2, 30 times the second element in column 2, 2. So you can see that 10 by 8 plus 30 by 2. Alright, so it's going to be 10 times 8 plus now 30 times 2. So there we have it. So what have we got here? 75, 35 plus 2, 9, 29, 180. 7, 8, 56 plus 22, 40. 10, 5 is 50 plus 3, 9 is 27. This is 270. 10, 8, 80 plus 32, 60. So that's what we've got here. So now we have 30 plus 180. 180 plus 20, that's 200 plus 15 more, 215. So that's 215 here. 56 plus 40. 50 and 40, that's 90 plus 6, 96. And we have 270 plus 50, 270, 30 will go to 300, and then 20 more with 320. That's 320. 8 and 6, 15. So this is 150. Alright, so that's the answer we've got here. Now, this matrix now, we're going to show that this matrix is singular. It's a singular matrix. So how do we do that? We find the determinant. And if the determinant is 0, then it is a singular matrix. So let's see what happens here. The determinant, remember, if we have a matrix in the form A, B, C, D, the determinant of that matrix is AD minus BC. So let's see how it works with this matrix. It's going to be 15 by 4 minus 20 by 3, which is 15, 4, 60 minus 23, 60 equals 0. It is indeed a singular matrix. We would not be able to find the inverse of this matrix because what happened? The inverse would be 1 over the determinant multiplied by, you interchange A and D, interchange 15 and 4. 4 goes where the 15 was and 15 goes where the 4 was, and then change the sign of B and C, negative 20, negative 3. So when you see that you have 1 divided by 0, you're not allowed to divide by 0. It can't work. So in that case, it is indeterminate. Or what you can say is this is undefined. You cannot determine it, but the usual thing is to say it is undefined. You cannot find the inverse of a singular matrix. Alright, so that's it for now.